Thanks everyone for coming. I'm not sure if the cryptic title helped bring people here or not, or you're just a very trusting audience. I work on ft.com, which is one of the fastest media sites on the planet. Sounds quite grand saying it like that. We also sponsor London WebPerf, so it's about time that we shared a bit of information about how we make it so fast. So a bit more about me. I've been an engineer on ft.com for about 4 years. And for about the last year, I've mainly concentrated on performance. I've picked up a fair bit along that time, but still plenty of gaps in my knowledge. And I like lots of things, but don't like React. Also, a little plug for our team. Next year, we've got some interesting things coming up, and the team's expanding, so we're hiring at the moment. So if what I talk about tonight or talking with the various FT employees here sounds interesting, please do consider applying. So tonight, I'm going to talk about a few things. Firstly, I'll introduce you to our tech stack, tell you a bit about how it works and why we made the decisions we have. I'll explain a little bit about how those choices can really annoyingly sometimes conflict with trying to optimize performance. And I'll share a few examples of how we work around these problems. But the main motivation behind speaking tonight is a lot of it's been quite painful. You can often turn up to performance talks and people say, oh, do this, do that, it's dead easy. Look at this simple example. You can definitely do this. And then you try and do that on your site and it's not that simple. So a lot of things I'm talking about have been quite painful. I think it's quite therapeutic to share that a site which is ostensibly quite good at performance actually finds it really difficult to do. Okay, some water. So I'll start by telling you a little bit about where we've come from. So about 3 years ago, when I started working at the FT, that's what ft.com looked like. I'm sure it was cutting edge at some point, but it isn't anymore. So it also was very slow. I don't know if you can see from the back, but it gets 2 out of 100 in the Lighthouse performance tests, which is maybe a little bit unfair because a lot of the technologies that Lighthouse tests for didn't exist at the time, but also it took 9.5 seconds to load, which is pretty rubbish. I don't tend to wait around that long for my news. So something which you can't see or can't experience unless you work on it is it was also very, very difficult and slow and dangerous to work on. So we had multiple test environments. We had QA, integration, pre-prod, prod, those things like that. And because of all that, it took a long time to release anything into production. And it'd typically be 1 release every month, which was, I remember when I started at the FT, they just released the new navigation, which everyone's really proud of, but it didn't really work. And that was quite typical of working on the site in those days. So life finds a way, as they say. And so people found loads of workarounds to put all kinds of rubbish onto the site. So this was also a really negative thing about the old ft.com. So a new department called Strategic Projects was formed. The idea behind this was they would start experimenting with releasing good stuff, so not hacky stuff that some other department put in, so good stuff that web developers could be proud of and releasing it quickly onto the site. And that team gradually became the team that built the new ft.com. And this is sort of the key slide of tonight, so try and remember this idea throughout the talk. That a guiding principle of the new ft.com is if we ever need another strategic products department in order to be able to release good stuff, then we've done something badly wrong. Okay, so once we'd sort of decided that we needed to change our approach to building the site, then came, obviously to add substance to that, there are various practices we follow. So first of all, on Falcon, nobody really owned the code base. It was shared between lots of departments. Loads of stuff was chucked on there, not evaluated to see if it was a good idea, just kind of stayed on there forever, causing bloat and vulnerabilities and things like that. So when approaching rebuilding FT.com, the tech team insisted on having full control over what went onto the site, everything it delivered, which kind of sounds confrontational. And it probably was a bit. I wasn't very involved. I think the business bought into it as well because they understood what a bad place we'd got to with the old site. So empowering the tech team to make the right decisions about how to build it, that was fundamental to rebuilding the site. A second thing that we hold very dear to our hearts, developing FT.com, is we release straight to production. So we have two environments. We have your local development machine, then you merge your code into master, and within about 10 minutes, that's serving live production traffic. So why do we insist on doing that? This means that we can do smaller releases. So our releases hold fewer moving parts, and as a result, they tend to have fewer bugs. It's easier to find the bugs and to fix them. When you've got multiple integration environments, all sorts of bugs to do with configuration between and replicating those environments to make sure they mirror each other properly, those can creep in. We don't really have them. They almost never happen. This approach enables us to release a small idea and iterate on it really quickly. So if we had a monthly release cycle, we couldn't do that. But as it is, with the new FT.com, we can release a basic MVP and then the next day release a change to it and keep doing that. So it enables us to really make sure we're building the right things for our users. And finally, it is quite good fun and empowering, and you do get a bit of a rush releasing something really dangerous to real users. Yeah. So something that enables that approach is feature flags. So imagine if you're building a big complex feature, releasing that straight into production is a bit dangerous. So what we tend to do, we have feature flags which hide work in progress from our users. So we can work on the code for that bit by bit, release a tiny bit of the feature, our testers can test it in the production environment. And when everybody, testers, stakeholders, is happy with the condition of it, to release it, we just flip the flag on and all our users see it. So without that, it would be very difficult to take this releasing straight to production approach because the things we'd be releasing would be too big and too complex. A bit more water. So that picture you're looking at while I was drinking my water, that's a rough image of the FT.com stack. We really go to town on microservices. Essentially, we have, instead of having a big monolithic app, we have lots of small services which do small jobs and interact with each other. And the reason we do that, or the reasons, is it's quick and easy to understand each service. It's easy to get up and running. It's really easy to deploy. We can, rather than having massive test suite for your entire application, you deploy little bits of it really easily. It's really easy to scale the application. For instance, our article app scale to lots of big boxes, whereas a feedback form is just one tiny box, and you can scale bits independently. And if something goes wrong with one of the applications, that tends to not leak out to the rest of the stack. So it gives us quite a lot of fault tolerance and resilience. In a similar vein, we build our front end mainly using an in-house component library called Origami. So a typical page on FT.com will use 30 or more Origami components, which range from something really low level like a font loader to buttons to more complex things like an overlay. And again, the reasons we do that is it breaks our code base into small comprehensible pieces, which is a lot easier for people to get up and running with. It avoids us duplicating work. And the FT doesn't just run FT.com, it also has about a dozen other sites. So it's a good way to maintain consistency across all them and we can really build really high quality things. So we're quite proud of accessibility on ft.com. That is supported in part by Origami, and the work that goes into making those components accessible then gets spread onto our other websites. So trying to find a thread in those things. What they have in common, roughly speaking, is they are all things that enable us to release good quality software quickly, frequently, and with confidence. So those choices really help us obtain the original aim of being easier to release good stuff onto ft.com, which we'd failed to do with Falcon. So, but you all come here to hear about performance. So bearing all that tech stack stuff in mind, I'm going to tell you a handful of case studies of how we have worked on performance on ft.com and how those technical choices have interacted with that. So firstly, I'll tell you about the paywall, which is built using microservices, and how we've optimized the performance of our front end, which is built with all these components. And then I'll talk a little bit about service workers and how you can get confidence releasing them straight to production. What was that? Okay. Forward's not back. Okay, so we hear a lot about the critical path. Most times I've heard it references with respect to inlining CSS. So the idea is to speed up your page load. Instead of waiting for a style sheet to come back from the network, you actually inline the contents of that style sheet so your page renders quicker. But more broadly, the critical path, it means every request that needs to be fulfilled in order to serve something useful to your user. And when you adopt microservices, you get things like that diagram there, where instead of having one app causing some latency to serve your user, you've got a big chain of requests, and each one of them adds its own bit of latency onto the final request to the user. So looking at that, it looks like microservices can be an enemy of performance. But you can help yourself by having a good caching layer. So the caching layer there, anything below that, if the user's request matches something in the cache, then it doesn't need to go all the way down the chain. It can stop at the caching layer, and therefore you reduce the latency. So if we're going to use microservices, we probably need to look into our caching options. How do we do for time? So because we have a paywall, unlike a lot of other news sites where someone just requests an article and you send it to them, you send the same article page to everyone, we actually vary the response depending on who you are. So you can see on the picture there, we've got an article page and a barrier page, and they're both served on exactly the same URL. And the decision about what to serve to each user, it involves some sort of deep business logic, understanding the user. So it happens really deep down in our stack. So it's difficult to kind of know which page to serve to a user at a level where you're able to cache it. And yet we have a really high cache hit ratio of about 90%. So how do we maintain that? So this is the starting point. You have a user who has a cookie, and cookies are unique per user. And you go down to our caching layer, which is CDN provided by Fastly. And that goes down to the application. It reads the cookie, and when sending a response, it says, I've generated a response unique to this cookie, sets the very header of a cookie, that goes up, and that's not going to be shareable by any other users because of how unique the cookie is. So what we really need to do is change it so the application isn't varying on the cookies, so it can vary on something a bit less specific to the user. And the way we do this, we have an application off to the side of the caching layer, which does that for us. So what does Preflight do? It's basically a service which reads the cookie, figures out what the information in it is, and then it uses that to allocate values to a smaller set of headers. So there we've got whether you're logged in or not, which edition you've chosen, and what your A/B test settings are. So we started off with maybe 300,000 users per day, but they all fit into buckets of maybe, I don't know, there might be 40 buckets of users. So I probably should have done the maths there, but but that means you can share a page between thousands of users. So you're going to get a reasonably satisfactory cache hit rate. So what happens there? So the CDN calls preflight. Preflight comes back with all these extra headers, which the request gets decorated before checking the cache. That goes down to the application. And now the application is able to say, okay, these are the bits of information I need to vary on. And when it sends the response up to the cache, it provides those in headers, and the cache is split accordingly. So the cache we get is highly cacheable, which means that most of the stuff down there is not in the critical path most of the time, which is quite a big win. We take a hell of a lot of requests out of our critical path. But we now have a performance bottleneck in pre-flight. That's not so bad, it's just one service. Or is it? That is what pre-flight looks like in real life, more or less. And that is all the performance bottleneck. Awful. So how can we improve that? I confess I did invent this name of the game for the talk, but I quite like it. Gives me an excuse to use a GIF. So essentially, you look at all your microservices, try and find the one that's slower than all the others. You just keep on hitting it until it's not the slowest one anymore. Then you find the next slowest one, you pick on that instead. So there's no magic tricks to it really, but I can offer a few hints on what will help you to achieve that. So the first thing is measure everything. Within our stack, every single request from one request to another is measured at both ends, so we know how long it takes the service to send a response back, and we know how long the service that requested it waits. And with this information, so on my graph there, you see at the far left, the access service was the slowest. In the middle, we had a big wobble in our A/B testing service. So further on measuring, it's really important to measure granularly. Trust me to put a word I can't pronounce in my talk. So yes, your measurements have to be granular. So imagine you've got an application, so Preflight might have two types of requests from logged in users and non-logged in users. Now they may follow completely different code paths through your application, or when it comes to microservices, they may get sent, the request may get sent off to completely different places. So the timings for those two different kinds of requests can be drastically different. So it's really important to try and make sure the things you measure are split along the same kind of lines as your code paths. I won't be the first person who said this, but the mean is not a very good measure. It tends to get distorted by outliers. So try and use the median, the 95th, and other percentiles that give you a much better picture of what is really the slowest application. Whether it's the median or the 95th that matters most to you will depend on your particular business case, but they're far more useful than the mean. Look out for timeouts. It happened a few times to us that because you're looking on a graph of averages of response times, timeouts, they kind of fall off that graph because it's not a numerical value, just counting how many responses time out. It's very easy to forget to look at those values. So geography, when your application isn't contained in one computer, how close it is to the other applications matters a lot for performance. So what happened a few times, again, is something went wrong in our routing layer, and requests which should have gone from one server in a server farm in Dublin to another server in the same room. They actually ended up getting sent all the way over to Virginia in America and back. So that if you get sort of big, unexplainable blips in your performance, it might be something like that. So request overheads, whenever you send a request between services, there's like the DNS lookup, there's a HTTP handshake. So there are probably in other languages as well ways to avoid doing that. A really easy way to minimize the amount of time you wait for that to happen is to use HTTP agents with Keep Alive in Node. So what that does is it has a pool of open HTTP requests, and it just reuses them. So that had, we use that in most of our services now, and that's just had a massive impact on performance. It's really easy to do. Then finally, once you've finished whacking all the moles and got performance down to a level you're happy with, regressions will happen and the business will move on and not fund your team to do it anymore, possibly. So it's quite impossible, quite important to get an agreement that this is a good level and we're not going to get worse than that. So argue with your business for a performance budget, which essentially means if things get slower, we're just going to throw away the response in future. Now that, there's probably a whole talk in that, because the kind of discussions you have with your business, and it's probably a whole talk where I wouldn't be able to talk about, wouldn't actually be able to share the information, but I've got permission to share a document that went to the board to try and persuade them to adopt a performance budget, which I'll share a link to that later. So, results of all that mole bashing are our payroll responds in 20 milliseconds for most of the time. Because of the perf budget, it never takes longer than 200 milliseconds. So that makes us, despite having all our articles behind a paywall, we're still very competitive, even with other free news sites. So we've got high cache hit rate, which as well as the speed benefits, also gives us resilience. So if our pages go down, we don't serve error pages to our users. And we also save quite a lot of money because the stuff in the critical path, which has to handle every request, is off to one side. There's a massive chunk of our application which we can really scale down and not spend so much money on. And I suppose to sum up this section, just remembering back to the principles of how we developed FT.com at the start, we've managed to deliver all this without compromising on our ability to keep releasing code all the time. We're still able to release pre-flight and related applications. We can release them as many times as we like in a day, release straight to production. Yes, so managed to achieve performance here without compromising. Okay, so the next story I'll tell you. This is the most painful one. This is good for me. This is real therapy, and for the team as well. These are kind of what I see as the fundamentals of a performant front end. If you visit a site and you come back there the next day, you would expect that a lot of the assets that built the page the first time can be reused. Because if not, you're going to have to download a lot more stuff. It's going to take a lot longer to display stuff to you. Another principle, when you're navigating around a site, you would expect when you go from page to page, if they look quite similar, that again, a lot of the assets that build a page can be shared between them and you don't have to keep downloading more and more stuff before you can see stuff. So those have been around for quite a long time. I think those have always been true. And then in this day and age, with lots of new things coming in browsers, we have lots of other best practices which we should do, such as responsive images, lazy loading things, and inlining critical CSS. So that's kind of what we were aiming for with the front end of FT.com. So how was it doing? Those two pages, that's the article page and the front page, blink or squint and you can really tell the difference between them. So they do share a lot of the design elements, and because of the components that we use, that actually translates into them using a lot of the same code base as each other. 50% is probably a very, very conservative estimate. But at the time, they didn't share any JavaScript or CSS assets. And if you visited a page and then came back the next day, you probably would not be reusing any of the same assets there either. And we weren't able to inline any of our CSS. So at the time, our pages were probably taking about 5 seconds to load. For reference, now that's 2 seconds or less. So what do we do to improve on that? Oh no, I got ahead of myself. I should explain why it was so bad at the time. So the reason that we didn't really cache things between visits to the site, which had lots of components which had their own release cycles, and our site as well, because we deployed to production several times a day, this would mean we bust the cache because the content of those files would change slightly, and the built files would be different, and it wouldn't serve the same file from the cache. As far as sharing resources between different apps, so our front end is built out of about 12 different microservices. They're all completely independent of each other. They all have the same their own build and release cycles. So if one app builds itself, the build tells the app what the assets are, and that app is allowed to get hold of those assets. But another application built by a different build process won't have a clue which assets to grab from the network. So again, because of componentization and this sort of reuse of code in slightly different ways in different applications, it's difficult to make. Sorry, frog in my throat. Yeah, it's difficult to make decisions about which CSS to inline on which pages. So we didn't do it for a very long time. And all this performance optimizations, we're not talking about applying them to a single application. This is about 10 or more applications. So it's an awful lot of work, a lot of coordination to be done. Some possible solutions that we could have adopted. Semver has a very bad reputation these days. People talk a lot about locking down your versions because it's safer. But actually, most of the components we use on our front end, they're built by another team that we sit very close to, get on with, and we trust them to do a good job. And in return for that, we get consistency and efficiency. So if there's some change to the branding of the organization or the legal team want us to change the copyright statement or something, all we have to do is kick off a build and we get all those changes. So it's really efficient, allows us to work really quickly. And if we were to lock down our versions, that would be taken away from us. So another idea that sort of did the rounds briefly was, can we just have a single front-end app instead of these 12 applications? But there's problems with that as well. So every single application will have its own quirks, particularly with regard to the build process. So the sign-up app, for instance, all its tests depend on a load of mock services, which mock credit card responses. So that's really quite flaky. So if we combine that with the app that serves our article pages, for instance, then that flakiness gets into the build for the article pages. So something which at the moment prevents us from releasing code for just one small bit of the site would prevent us releasing for the entirety of the site. So again, having a single front-end app would make it much harder to release changes to ft.com and take us a bit further away from that aim of never needing to spin up a new department to release code. So in the end, we decided we're probably going to need to build some kind of thing to help us with this. So we built, the name of that thing was NUI. So this diagram hopefully conveys that there's a lot going on in NUI. It's quite complex. you can look at that diagram later to your heart's content. But to summarize, it's a build process and a server and a load of client-side stuff to orchestrate loading all the bits and pieces of the page in the most performant way possible. So we released that. I was really happy with it. But then, I don't know if you ever baked a cake, and to you it looks like that. It's just a thing of beauty, best cake in the world. And you present it to your friends, and they politely inform you that it looks a bit more like that. So that's kind of the story behind NUI. It is a big falling to earth. So within days of releasing it, I had to contend with all this. I even wrote a blog post on how good a solution it was, and then had to burn it. I think the most, within the context of this talk, the most depressing thing about all that is that when I described how Falcon was in the bad old days, that's very similar. It's a load of people unable to release good things easily. So we'd accidentally really messed up there. So what did we do wrong? I think the major lesson from this is not to build a performance thing by yourself. So there are definite benefits to isolating performance complexity on the front end from other bits of your code base. I'd say performance optimization is probably one of the more complex aspects of front-end coding, at least the kind of website that we work on. So if that's kind of leaking out all over the code base, that is going to be painful for people. But when you do abstract it away, I think we lost sight of the fact that those abstractions are not going to be perfect. So you can't just run away and build a really complex thing which does all the jobs that no one else wants to touch, because sooner or later, someone else is going to have to touch them. And if you've gone away and built it by yourself, then there's a good chance, particularly if you're me, no one else will understand it. So we have moved on from there, I'm glad to say. So what have we done? We've retreated from quite a few of the sort of too clever ideas. So optimizing performance is tricky, particularly when you've got this the front end that I just described. And sometimes it's just not worth the pain. You may get a small incremental improvement in performance. Maybe something you saw loads of conference talks on, you should definitely do this. But if you apply it to your own stack and you realize it just adds a load of stuff which is difficult to maintain and no one understands, then you don't have to do it. You really don't. It's annoying not being able to do it, but sometimes the choice is just to walk away. I haven't got any notes for this slide here. Okay, so as a result of that simplification, things are starting to look a bit more positive. So NUI has got progressively simpler and simpler, and now a lot of the ideas of what to do next are coming from the team. So we're probably going to roll out Brotli compression and use some more advanced Webpack features. And they are things that the team are coming to me and saying, yes, we'd like to do this in NUI. And part of the reason I think that happens is initially NUI was something done to the team, and we had several updates to remove the complexity. They were all done in collaboration with the team. We held sort of small workshops where everyone got together and updated it across the site. And also, I think when we were producing NUI, it was that period where it was on Webpack 1. That was a bit rubbish. And now I think the tooling's improving, the web platform's improving with things like ES6 modules. So a lot of this complexity will gradually melt away, which I think is another reason to maybe not to kind of walk away from it if things are getting too complex. Oh, I forgot to sum that bit up. So anyway, last story I'm going to share with you. Yeah, thanks, Simon. Is releasing service workers straight to production. This has got my favorite slide in it. So firstly, why would you want to use a service worker? Who's heard of service workers, by the way? Guessing quite a few. Okay, so the things they give you are, number one, from a performance point of view, I'd say, is really persistent caching. So web browsers, particularly mobile browsers, you may send, let's say, a font with a header which says cache this forever. The browser doesn't really have to listen to that. But with a service worker, you can be pretty sure that the assets that you want to be there present in the browser for a long time are going to stay there. So that's the big win from my point of view. It's also the gateway to doing lots of other cool performance optimizations. You may have heard of the app shell model, where the scaffolding of the page is held in the browser and every page load just fills in the middle of the page. That makes page loads a lot quicker. That's enabled by service workers. It allows us to have greater resilience when the network lets us down, so you can have an offline experience. You can do things which native apps tend to have been able to do forever, but we have never been able to do in web pages, like push notifications, and it's pretty cool. Standing up here being very cool, talking about service workers. Okay, so here's a definition of service workers from NDN. Service workers essentially act as proxy servers that sit between web applications and the browser and the network. I've got another quote which I think really captures the spirit of service workers. I'll eat anything you want me to eat. I'll swallow anything you want me to swallow. So come on down and I'll chew on a dog. I think that really captures the spirit of what service workers can do to you. Another thing which really captures the spirit of service workers is a great talk by Alexander Pope, where his talk uses the metaphor, it's a graphic novel about a zombie invasion to describe his pain that he had dealing with service workers. I really recommend seeing that. It's much better tech talk than this one. So what happened when we tried service workers? We had some really, really serious bugs. So first one there is we showed barriers to every user when they were signed in, and people pay quite a lot to read FTP content, so that's terrible. During a transition period between moving between Falcon and the new site, I accidentally released something which meant if someone opted out of the new site, when they went back to the old site, they'd just see white. Which, our readers love this kind of pale pink, so they weren't happy with that. And also, this kind of thing in Alexander Pope's talk, he talks about a lot, is you can, for really obscure reasons, people can get stuck on broken service workers. They're really difficult to, even if you release a fix, it can be difficult to be sure that that fix has actually gone out properly. So anyway, after all these disasters, confidence in service workers plummeted at the FT. So again, what went wrong? We didn't have any tests. That wasn't us just being lazy. That was because service workers are difficult to test. At the time we were trying to work with service workers, you'd Google how to test a service worker, you'd just come across loads of pages of other people asking the same thing. What's the next point? So unlike the rest of our site, which is protected by feature flags, so we can gradually build up a complex feature, can't do that with service workers. We didn't have any mechanism for toggling features on and off in the service worker. And we had, because we only have a production environment, we didn't really have a test environment where we could try out this really dangerous, really difficult to clean up after yourself thing in a safe environment that our end users didn't touch. And finally, if a service worker broke, we hadn't really thought through how we were going to roll back from that. So before we tried service workers again, we had to go back to the drawing board on a few things. So the main takeaway from this slide is that service workers are difficult to test, but they're not impossible to test. So a lot of the APIs used in service workers, such as the new cache API, quite surprisingly, because I suppose you wouldn't really want to use them outside of a service worker, but they are available in the DOM. So you can write tests in just running a normal web page to test modules that interact with them. abstract them away a little bit and run as many of your tests just in a page. That get profile there, again, that's Alexander Pope. He's got some great service worker resources, including a mock service worker environment, which we probably would have used if it existed at the time. Test runners that whichever test runner you use now to run your tests can probably be adapted to run tests with a service worker as well. It's kind of a matter of spinning up a temporary service worker and communicating with using post message. Something to be really careful of is how you do cause. So whether something is a same domain request or not really affects the amount of information you get about the request in the service worker. So be careful, things which are the same domain requests in your production site, make sure they're the same domain requests in your tests. That's not enough detail. You'll probably write a blog post or something about this if people are interested. Okay, so we kind of needed a test environment as service workers were so dangerous. So this is pretty much the only bit of the site that we do have something that looks a bit like multiple environments. So we're able to serve service workers from a prod, a QA, or a canary URL, and choice of those URLs is controlled by the feature flag mechanism we use for all features on the site. And the way you release to those URLs is by tagging commits in GitHub. So if we've got a commit which we want our testers to test out, then we'll add a QA version 10 tag or something like that, and that will deploy to the QA service worker. And then they just flip a flag and they're able to test that in production without it impacting on any of our end users. And the final step of that is if we're about to release it, rather than releasing to 100% of users at once, we can flip another flag. Or we can release to the canary URL, flip another flag, and then 3% of our users will be using that service worker. We can observe it in production for a few days. If it's fine, then we just deploy it to the prod URL as well. So it's a much safer, more cautious release process. We also now have a mechanism for turning on features in a service worker using feature flags. So every page load gets sent the feature flags. In the pages code, we store those flags in IndexedDB, and the same IndexedDB is accessible from the service worker as from the page. So before, say, handling a request, before we decide whether to grab it from the cache or from the network, we check the value of the flag and make the decision accordingly. So that allows us to, say, for instance, we've got a push notification feature in the service worker, and we've got a caching feature. We can sort of turn them on and off independently and make changes to them independently. Okay, and the final thing, we really didn't pay enough attention to being able to turn our service worker off. They can be really difficult to get rid of. So don't cut corners. The link at the bottom again, Alexander Pope, loads of great resources. Watch his talk, he'll tell you about all the ways it could go wrong. Make sure you don't fall into those traps. Yes, so that I think, sorry, I forgot to say, our main mechanism for turning off a service worker is via feature flag. So if you flip a particular feature flag, that unregisters the service worker. It's the first bit of script to run in any page, so it unregisters it very, very aggressively. That's something you really want to be able to do. So we now have a service worker on ft.com because all those changes gave us the confidence to release one. So since the spring, we've enabled push notifications. They've been going fine for about 6 months. Most of our front end is now cached in the service worker, which, as I was explaining, gives you a lot more persistence in the cache, so a more performant front end. We're about to start, actually we turned it on today, got an experiment to improve ad load times using service workers. So ads are often terrible for performance, and we're hoping to improve ad load times per second or two. Famous last words, it probably won't be that good. It'll be like 10 milliseconds or something. And all this has been rolled out with, there's been bits of weirdness every now and then, but we're pretty sure that there's actually been 0 user-facing bugs because of this. We haven't, the kind of catastrophes we got back last autumn just haven't happened. And this gives us quite a lot of confidence to go forward and sort of add more progressive web app type features to ft.com. So once again, we took a really difficult bit of performance optimization, but we managed to get it work without compromising on the core values of how we build ft.com. So coming to the end now, let's go over that writing a summary slide is one of the hardest bits of writing a talk. What can you take from this? I think that the way we choose to build complex applications is really important. We invest time in how we do those things to make it easy to do other things in future. And we should really hold those close to our hearts and not give up on them, even when they conflict with other things. So performance is another complex thing, which can sometimes make it difficult to hold to the principles of how you build something. But they can be made to work together. And as I was saying earlier, the group therapy element of this talk, I think it's important to share that we have one of the fastest media sites on the website, and hopefully you've all seen that we're far from perfect. So hopefully that gives people confidence that you don't have to be perfect when you're addressing performance. You'll probably still get great results. Oh, and we're hiring, and thank you.
I hope you all agree that that was a really great talk. I think that was, fantastic. I've got one question for you before I kind of open it up to the floor. Then we are going to have questions, right? But it was right at the start of the talk, you talked about, releasing straight into production, but you control it with feature flags. Mm-hmm. Well, when you released the feature flag code, how did you test that? did that go straight into production or not? Or is
yeah, that breaks all the time.
Yeah, that breaks all the
time. It's quite a simple service. I think it's the answer to that.
Yeah. Okay. So there we go. Anyway, so have we got any questions from the floor? Yep.
Thanks for the talk. I know about a year ago you guys released an interesting article about engagement and performance. Mm-hmm. Was that on the back end of some of these changes, or have you looked at how engagement has changed since you've made some of these changes?
Was that was an A/B test to see how it impacted?
Yeah, I think so.
That actually, probably about a year into the new ft.com, that helped. So ft.com was gradually being built for about a year, and there were quite a few people in the tech team advocating for making performance a priority. And that A/B test was run in order to convince the business to invest in that. And on the back of that, we had a performance team, a few people dedicated to working on performance for a while. So yeah, that really helped persuade the business to invest in it.
But you haven't gone back and measured the benefits of all this work from a business standpoint?
Well, no, other than the fact that research we did artificially slow the site down. So we had various data points of what impact performance has on engagement. We could run that test again, but I think we were fairly convinced that a faster site, along all those data points, did influence users in a positive way.
Any more? There's one over here and one here. I'll go over here first.
Hi, thanks for the talk. It was very interesting. You talked at one point about inlining CSS. I mean, have you looked at all at HTTP2 and alternatives to doing that server push, that kind of thing?
Yeah, it's something we've considered. I think a lot of the work we've done most of the hard work with inlining CSS is identifying what to inline. And once you've done that, you're most of the way to being able to do HTTP2 push. Thing that concerns me is, I think we were thinking about doing it about 6 months ago, or maybe a bit longer than that. I think at the last Christmas talk, there were a few talks at the last Christmas London Web Perf. There's 1 or 2 talks about push and how that compares to inlining stuff. And it's not so clear cut that it's always the best choice. Trying to think who delivered that talk. If you look in the archive of London Web Perf, there's plenty of stuff to indicate that's a trade-off, and it's not a silver bullet.
Hi, that was awesome. Thanks. So the thing that's really interesting to me is like your CI/CD pipeline and feature flags. But I was really interested in because the really important thing is understanding like if it's working well for customers. So I was wondering how you instrument your front end and you're collecting those the telemetry from your applications.
You mean customer analytics?
Yeah, for all the performance things and the features, and you know if this is a successful deployment or not.
As in successful, as in doesn't make it slower.
Yeah, so regression and maybe adoption as well.
Again, there's scope for group therapy there. It's not easy. We're kind of use a few tools. Our speed curve is something a lot of people have heard of, so we have that running daily, and we have alerts going into Slack to tell people about whether things have gone slower or not. When you've got such a big distributed system, it's quite difficult to pin down exactly what's caused what regression. I'm not going to try and tell you I've got a perfect answer to that. Don't. It's something we're aware we don't do well enough. Yeah.
Anyone else? Are you going to talk about recruiting?
Hi, Reese. Great talk. I hear
I've never met you before in my life, have I?
I hear there are some roles at the FT. What exactly are those roles? And would it be a good team to work for?
Yes, it would. We're looking for Node.js full stack developers. You get to work with me, with Simon, with a bunch of other people here, so please talk to them. Yeah, if all that stuff I talked about sounds interesting, we're still doing all that now. So yeah, speak to us, come work with us.
Yeah, in terms of the question about HTTP2, I can't recall exactly which month and which talks these were, but if you go to like londonwebperf.org/events and like scroll through the list, you'll be able to find it. It's one of the feature requests that we've got is to do a search across our previous events to make it easier to find stuff. But if it was around December last year, then that should be fairly easy to kind of pin it down. And all the slide decks and all the videos are linked straight from each talk on the site. So you should be able to find it if you need it. Question at the back, or just like putting your hand, do you want to go to the toilet or something? It's there. No.
So a sort of non-technical question. The FT suffered some attrition of high-profile people who cared about performance. But yet, yeah, sorry, Patrick. But yeah, you've maintained a culture of performance despite that. You've built it in. And, you know, how did you do that? I think is an interesting question. Or perhaps it's too hard to ask.
How do we do that? I mean, it's interesting work on performance. It's a really interesting area. I think we recruit a lot of junior developers. Whenever I talk to them, it's always, yeah, it seems like doing proper development, doing something really interesting and where the value is really obvious. So I think there's a lot of enthusiasm about it. You don't need to do much about that. So culture, I mean, the first question from the front was, we did do a study long time ago now to check the impact of performance on engagement, and that still gets talked about now. So we get a lot of buy-in from other disciplines, all the way up to once I had the chief executive ask me about performance. So it's, you know, all the way through the organization, people care about performance. That doesn't always translate into actually getting the time and the resources to work on it, because there's always lots of other demands. So it's imperfect, but I would say like the foundations of the business caring and our staff caring are just there, and they're not so hard to work for.
Cool, thank you.
Yeah, and I'll do my sales pitch again now. So saying if you want to find out about more that kind of thing, come to Delta V next May. You know, we'll do stuff. I think it's really testament to the FT actually, and the people that Andy was alluding to there that kind of really sort of set the whole field of performance at the FT kind of on track, and that the younger and newer staff that have come along have kind of learnt from those people, and they've stayed with this community. Those people are always a big part of this community, and you know, everyone's kind of kept up with it and applied those learnings. So I think that's really testament that not only to the staff but also to the business here, and actually appreciating the significance of performance. And so I think, you know, it's got a big part to play. Go on down the front here.
In chasing application performance, have you ever found that developer performance has been affected? So it might be that the system is going slightly quicker, but that it's now taken a lot more time, or it's a lot more difficult for developers to make changes?
I think that's when I was talking about the front end, that definitely happened for a while, and that's why we kind of stepped back from the kind of crazy pursuit of performance at all costs. But on the server side, it's not. For individual services, it's not. It doesn't feel like there's so much of a conflict about that. I think it can add complexity to your kind of grander scale architectures. So just having a request go down to an application and back up again, that's a lot simpler than the picture I painted. So yeah, there's definitely overhead in understanding the entire system, what they can be. But individual applications, all our applications are, you can get up and running in about, I don't know, a minute. Just clone it, install it, run it. They're all really easy to work with.
Would there be an example of a time when you've implemented something for application performance and you've actually decided, no, we don't want to do this, this is impacting developers too much? Or
yeah, so on the front end, NUI started off as a much bigger thing. The idea was any bit of sort of front end component code that could exist, that is used in our applications, that should be kind of, NUI should be the single source of truth of how you use it, how you interact with it, how you configure it. And it was just made everyone's mind melt. It was that, you know, we had a big component system. The way you're supposed to work with components is you install the component, interact with it directly, and we put this layer of complexity between developers and these components. And that was slightly good for performance. It meant the bundles of code we were sharing between our applications were a bit bigger. So users had to wait a tiny bit less time to get their code. But yeah, it wasn't worth the cost.
Yeah, I think that was a really good question. I think it's again to the thing you brought up, the point about budgets. Actually, when you get to a point where it's kind of good enough, yeah, like set your budget at good enough level rather than, let's say, the absolute bottom end that it can be, because you've got to strike a balance. Every business is facing huge challenges to like kind of deliver their products to market, and performance is one of those. You know, there's been a lot of studies about the impact of performance on engagement and bottom line revenues if it's e-commerce, or ad sales if you're kind of like in that particular market. But you've got to find the right kind of level, and that's where it becomes it needs to be a discussion between us in engineering and product, and through product into the business to get that kind of overall right level. I thought you put your hand up then, Patrick, but maybe you were just scratching.
Yeah, thanks again for the talk. I noticed that on mobile, the FT website used to be an add to home screen app, and well, recently I may have been in a tiny A/B test, but it directed me to install the native app. Given it was super slick and smooth, and you've done all these performance optimizations, what was the sort of reason for pushing to the native app?
Well, they're two different things. So we've got the website, which is the new thing. We've got the web app, which is a bit older. Which is, I mean, the reasons for the FT leaving the App Store were to do with sort of, I don't know how much I should say legally, but they were to do with disputes about subscriptions and stuff like that, and how the FT handles them. Those disputes were resolved, and if you've got an app in the App Store, people are more likely to install it. So it's kind of not really to do with anything to do with performance or anything about saying the web is worse. It's just, it's a shopfront, and we wanted to get something in that shopfront.
Hi. Yeah, sorry, maybe slightly off topic, but why do you dislike React? Is it from a performance perspective? Is it a performance-based thing, or is it just a personal?
Well, on the subject of performance, I've been a developer a long time, and people used to say the DOM is a terrible API, and it was. Now it's pretty good, and there's lots of new stuff landing all the time, which is really good for performance and really good for other things. And I really dislike how React says, no, stay away from the DOM, it's mine. Which I think is changing in the latest edition of React. There's some way of kind of letting go of bits of the DOM in a less all or nothing way than the methods which were allowed in older versions. That's my main objection to it. And I think it's used for things. It's a good. I've used it. It's a good tool for some things, but I think it's, you hear people saying when all you've got is a hammer, every screw looks like a nail. It's kind of like that. I just feel like people bang the React hammer.
Great, thanks.
I could go into why I don't like Game of Thrones as well.
Hi, can you tell us a bit about the service worker ad loading experiment that you're doing?
So when you load an ad, way before you actually get the ad creative, there's a load of like a waterfall of requests to target the ad. A lot of them, they don't change very much. So we're just experimenting with caching them for short periods of time in the service worker. So as you go through the site, a lot of those requests are instant, and then you can very quickly make a call for the ad creative. Sorry? Like what, sorry? Header bidding? I don't know too much about what the individual requests do. I just know there are lots of them, and the content of the responses seems to barely change, so I may as well try and cache them.
Okay, that sounds like that is the end of the Q&A session. So I'd just like to, thank you for the Q&A. That was fantastic. Well, you for the Q and you for the A. And just like to give another round of applause to Reese for a fantastic talk tonight.